Okay, there are so many ways to find the gradient of a graph. In math method, you have to learn two ways. Okay? The first way is called first principle. Okay? The second way is called differentiation. Okay, and okay, so in this tutorial, I will teach you how to use differentiation, and I will do a tutorial on first principle later. Okay. Okay, and both first principle and differentiation is going to be on your year 12 final year exam. Okay, and okay, and I will explain the difference between them later. Okay, now let's concentrate on differentiation. Okay, uh, differentiation is basically to use those formulas to find the gradient of the graph. Okay, today I will teach you how to okay, here, sorry, on your right hand side. Okay, uh, okay, actually they are the okay, this is some formulas, and it is available in your book. Also, it will be given in the final year exam. That means you can find it in your year 12 exam paper. You don't have to memorize it. Uh, well, you have just learn how to use them. Okay. 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 Now let me tell you this one. Okay. Let's start with the first formula here. Okay. Um, okay. Okay. I do an example for you. Okay. Example: if I want to find the gradient at the gradient of the graph y equals to x squared at x equals to 1. Okay, what do I do is I differentiate. Okay. The way to do it is I have y, let me just rewrite it. I copy down my question, y equals to x squared, and I differentiate. The simple is dy on dx. Okay. This is the simple in for differentiation. Okay, and equals to 2x using the formula here. So when y equals to x power of n, the differentiation of the of this function, okay, is going to be n times x power of n minus 1. Okay. The all I can say is move the power to the front, and left is with minus 1, and I will have when I do a differentiation using the formulas there, I will have 2x. Okay, that means after differentiation you will have a function, and this function it's the it is the gradient of the original graph. Okay. Graph. Okay. Okay, so after I have the differentiation function, I just substitute x equals to 1 to differentiation function. So I will have dy dx, which means the gradient, okay, will be equals to 2 times 1, which is 2. Okay, so at x equals to 1 on graph y equals to x squared, the gradient, or I can just write down the dy dx equals to 1. Okay, dy dx means the gradient. Okay, this is how do we do it. I will do some more examples, but for now, just let me introduce some mathematical symbols. Okay. For example, if I have a function of x equals to x squared, okay, the differentiation or the gradient of this function will be function, put a comma after f, and you x equals to 2x, and when the differentiation function, okay, and I substitute x equals to 1 will be 2 times 1, which is 2. Okay. They are basically similar stuff there. Okay. This stuff is similar to what I did here, just in different notations, different mathematical symbols. The idea you have to remember is when the question is given in y equals to x squared, and you have to use the simple dy on dx for gradient. But if they gave you in the question, they give you something like a function of x equals to x squared, then you have to leave the symbol in this form. Okay. It also means the gradient. So dy dx, okay, and f dash x, they have the same meaning but different symbols. Okay, they have the same meaning. Just don't be confused on that. Okay. I do some more work on this formula. Okay. So okay, with this formula, y equals to x power of n, and dy dx equals to n times x power of n minus 1, I can solve basically all the polynomial equations. Okay. Okay. For example, if I have a question, okay, yep. Okay, let's go back to the previous question first. If I have y equals to x squared, okay, and the differential equation will be 2x, okay, like what we previously did there. Move the power to the front, and the power has to be minus 1. Okay. And here, This one is your original function, original graph. Okay, and this one is the gradient of your original graph. Okay. If I draw them on the axis, I will have something like that. Okay, y equals to x squared. X belongs to R, and the gradient will be okay. And if I draw this, it will be something. It will be something like that. Okay, dy dx equals to 2x, and x belongs to R. Okay, what it okay. Actually, the differentiation dy dx means the gradient, but it gives you a function. Okay. Also, we can call it the gradient function. The gradient function. Okay. What's happened is, say I have a point A there. Okay. At when x equals to point A, okay, I say the point on the graph is P. Okay, the gradient of point P will be there. Okay, will be this value there. dy dx when x equals to A. Okay, basically the red graph shows us the gradient of the original graph and how it's changing. Okay. From here, point B is a minus. The gradient at point B is a minus number, say, and well, dy dx must be minus because it's in the minus area of y-axis. Okay. So for instance, if I want to find the gradient of point Q here, okay, what do I need to do is find the x coordinate of point Q first, and then I substitute it into the graph of into the dy dx function, and I will have this number there. Okay, this is the dy dx when x equals to, okay, say this is b when x equals to b. Okay. Yep, this is basically how does this thing works. Okay. The idea is when you ask to find a gradient of any point on a graph, okay, what we do is we find the gradient, okay, the differentiation of it, which is the gradient graph of the original graph, and we substitute the x coordinate into the dy dx graph, and we will find the answer there. Okay.